Welcome to The Scoop, NANP's monthly educational webinar series. I am your host, Andrea Granson, Education Programme Specialist for the NANP. These webinars are recorded and can be viewed at any time by logging into the NANP members area. NANP members can earn 1 continuing education credit for participating in Scoop webinars by taking the corresponding quiz, which can be found in the membership area of the NANP website. Okay, let's get started. Today, we present the missing links in mental and metabolic health, methylation, nitric oxide, and the microbiome with Brendan Vermeire. Brendan is a mental and metabolic health scientist and researcher, functional medicine educator, writer, and speaker. He is a board-certified holistic health practitioner, master nutrition coach, master personal trainer, USAW sports performance coach, and CrossFit trainer. He began his career as a personal trainer and nutrition coach at the age of 18 after disappointingly being medically discharged from the United States Navy SEAL training pipeline due to an injury. After being exposed to the power of functional lab testing in the start of his career, he began intensely pursuing that as a career path, which led him to be widely regarded as one of the top leading experts in metabolic health and functional education. He is the proud owner and founder of the Metabolic Solutions Institute for Functional Health and Fitness Practitioners and the creator of the Functional Mental Health Practitioner Certification course. He is also the founder of the Metabolic Solutions Research and Education Foundation, a not-for-profit foundation dedicated to changing the way the world views mental health through advancing the science of mental health dysfunction. He is also the creator of the Mental Map, a cutting-edge lab panel for mental health. When he's not educating doctors, practitioners, professionals, helping clients overcome their most severe health struggles, or producing cutting-edge scientific education, Brendan enjoys all things fitness and is probably working out. He also enjoys anything in nature and any activities that expand his heart, mind, and soul. Welcome, Brendan. Thank you for joining us today. We know this is your second time back, and we're really looking forward to this. It's now over to you.
Hello, functional friends. My name is Brendan Vermeire, and it's always such a pleasure to have the opportunity to get to share a little bit of my work with you all. So today I'm going to be giving a presentation on what I consider to be some of the most important missing links in mental and metabolic illness, which is methylation, nitric oxide, and the microbiome. So we have about 60 slides and about 60 minutes, so I want to get right to it so I can provide as much value as possible in the time given. So let's go ahead and get started. So liability disclaimer, of course, standard. This is copyrighted work. A little bit about me in my career overview, if you're not familiar with me and my body of work so far. This is my bio to learn a little bit more about my origins and my roots. My background is really nutrition and fitness, so I have a very metabolic focused background. And then these days, all of my work, my whole career really centers around functional medicine, specifically for metabolic and mental illness. So that's really kind of my claim to fame if I have one. So with presentation objectives, as far as what I'm going to strive to accomplish with the time that we have, I want to help you all gain familiarity with the concepts of microglial activation, methylation, nitric oxide synthase uncoupling, the nitrate pathway, and the role of the oral and gut microbiome with all of these pathways. We're going to try to increase the depth of our knowledge on the mechanisms by which methylation disturbances, nitric oxide dysregulation, and microbiome perturbations perpetuate one another in a rather vicious cycle at times. So I'll help you all gain insight into which clinical biomarkers and functional lab tests are going to be most pertinent for assessing, navigating, and monitoring recovery from these root cause dysfunctions, as well as introducing you all to some of my favorite therapeutic strategies and protocols for clinical success and positive outcomes with your patient or client population. So we'll see if I manage to accomplish all of that or not. So if you're not familiar with my work, I always like to start all of my lectures with this. This is my working theory. This really encapsulates everything about my career, the research that I do, the education I provide, and really what I'm all about. So I would really argue, and I postulate, that mental illness is largely an epigenetic phenomenon driven by oxidative stress, inflammation, and neuroendocrine dysregulation. Now, I'm very precise and calculated with my chosen words. So notice that I say largely, not exclusively. Certainly, there are other aspects to mental illness, and there's certainly the psychological and psycho-emotional and behavioral side of it. But as far as from more of a physiological, clinical perspective, I really stand by this statement, and this is really kind of my whole career working theory. I'm constantly essentially trying to prove myself wrong. And the deeper I get into my career, I haven't been able to prove myself wrong yet, which maybe means I might have something about this that might actually be right or truthful. So the journey continues. Now, we don't have the time, and I don't really have the interest to go into my long sort of sad story of some of the struggles that I've been through. However, I do think it's helpful to have a little bit of personability so you can understand what drives me, what motivates me, what makes me so passionate about these subjects, about these sciences, and really what I do. So on the left side of the slide here, we have a picture from a hospital bed. Now, this is just a Google image. This is not me in a hospital bed with my feet up. However, this is what my view was in February of 2014, after I woke up from a medically induced coma, after I had intentionally overdosed on my antidepressant drug, Wellbutrin. I had a suicide attempt and was unsuccessful, and was in a medically induced coma for about 3 days as they pumped my body and flushed my system and tried to get my liver enzymes out of the thousands. And so then I woke up in the intensive care unit and was in the intensive care unit for, I think, a total of 5 nights or so before I was transferred to an inpatient psychiatric ward where I quite literally was locked up against my will, not able to step outside, no contact with the outside world, not really able to exercise. I mean, I was trying to do push-ups and squats, body weight work in my room. No good nutrition at all, just really bad processed cafeteria, hospital food, handed tons of pills, belittled and condescended by psychiatrists that looked at me like I was this child that's unable to take care of myself or doesn't know anything, just this broken thing that needs to be mended with neuropsychiatric drugs, right? So this was February of 2014. I experienced firsthand just how dysfunctional the conventional approach to mental illness is. And these days, I'm happier and healthier than I've ever been. I've been medication free for about a decade, so I went through my own self-healing journey. And now it's a great honor and privilege to have the opportunity to pay it forward and share some of the knowledge and earned wisdom that I've collected over the course of time. So this is kind of my full-on transformation. This was, I believe, 2021 when I had the opportunity to give a lecture at the Integrative Medicine for Mental Health Conference, which is a pretty well-respected conference, functional medicine for mental health. And this was a lecture that I gave to hundreds of mostly MD psychiatrists. So to go from almost killing myself in 2014 to then teaching and lecturing a root cause approach to mental illness to hundreds of psychiatrists, that was a huge moment for me. So I just wanted to share that so you can appreciate where I'm coming from with why I think I should be speaking on this subject at all, right? Why am I qualified to be here? So I just want to make sure we're all on the same page with what we're up against with the mental and metabolic health crisis. So, in 2017, a study estimated that 792 million people, about 10.7% of the global population, are affected by a mental health disorder. The CDC data that I track every single year, I'm always keeping up with the CDC top 10 leading causes of death for Americans. In 2018, suicide was the 10th leading cause of death for all Americans, and it was the second leading cause of death for ages 10 to 34, and the fourth leading cause of death for ages 35 to 54. Suicide is still a leading cause of death for young people, but during the COVID pandemic, it did get bumped out of the top 10 causes of death. Now, of course, we see that a 2013 study showed 1 in 6 Americans take a psychiatric drug. That's over a decade old, so it's probably higher at this point. A study in 2020 found that between February 16th and March 15th of 2020, right at the beginning of the COVID pandemic, psychiatric prescription fills increased by 21%, and anti-anxiety prescriptions rose by 34.1%. And of course, we're already, as Americans, the greatest consumers of psychiatric drugs on the planet. Now, I do find it interesting that young men are the fastest growing demographic for consuming psychiatric drugs. I personally contributed to this statistic, so I find it particularly interesting. These are a couple heat maps. So on the left side, we have a heat map that's essentially showing suicide rates in the United States. So the darker the color, the more suicide happens within that state between the years of 2008 and 2014. Now, on the right side, we're looking at prescriptions for psychiatric drugs. And what we notice based on the heat map is that the diabetes belt of America, which is sort of this southeast region here, the Louisiana, Alabama, Georgia, so on and so forth, this region that's known as the diabetes belt also just so happens to consume more psychiatric drugs than any other region on planet Earth. Do we think that maybe there's a correlation perhaps between, the diabetes metabolic syndrome belt and suicide and psychiatric drugs, right? I'm painting a picture here. Now, to further that point, this left chart that comes from the World Bank shows suicide rates from 2000 to 2016. As we see, it's this gradual upward climb that continues to climb year by year. And then over here on the right side, we actually have obesity rates since 1990 up until 2018, up and up and up and up. So we see this positive correlation between obesity, diabetes, metabolic illness, neuropsychiatric drug utilization and consumption, as well as suicide, right? Now, of course, association doesn't equal causation, so we're going to keep this party going a little bit. I really like this one, so I'm going to read it. Less than a third of Americans taking an antidepressant have actually had an appointment with a mental health professional within the past year, suggesting a critical weakness in a system where medications are widely available, often prescribed by primary care physicians, as which was the case with me when I was 17 years old and first put on an SSRI. But holistic mental health care and frequent monitoring are not widely available. We see global antidepressant use with the United States well in the lead and Iceland behind. And this is a report of Medicare beneficiaries from 2010. So this data is 14 years old. Yet, even from 14 years ago, what we see is that about 90% of Medicare beneficiaries in 2010 that had depression had at least one other chronic condition. And if you follow the color graphics here, we can see that approximately 40% of Medicare beneficiaries from 2010 had at least 5 other chronic conditions, right? So I'm really trying to make the point that we really need to be thinking about the rise in mental health disorders as being essentially a side effect of the chronic disease epidemic. So to kind of finish up this conversation point so we can get into the good stuff, depression is currently affecting about 264 million people globally across all ages and is projected to become the second leading cause of worldwide disease and disability by 2030, which is only 6 years out. Now, dementia, Alzheimer's, which Alzheimer's is, I believe, the 6th or 7th leading cause of death, as the last I checked from the CDC, and cerebrovascular disease is right up there. It's, diabetes, cerebrovascular disease, dementia, all within the top 10, like 5, 6, 7 is approximately what they are. But Alzheimer's disease is the most common form of neurodegeneration and dementia, estimated to affect 36 million people worldwide, with this number predicted to triple by 2050, right? So this all opens up a lot of opportunity as healthcare practitioners, functional providers, what are we going to do about it, right? And that's what I'm here to try to help with. So for anybody that's familiar with my work, all of my work centers around the concepts of microglial activation, neuroinflammation, and neuroplasticity. You know, my main areas of research and focus is psychoneuroendocrine immunology, for those that are familiar, and metabolomics, essentially. So we're looking at the overlap of a lot of different systems within the body, because for a long time, we've kind of been sold this narrative by big pharma that, well, mental illness is, you know, primarily the result of like brain chemical imbalances. There's a genetic hereditary factor. We don't know why it happens. It's heterogeneous in origin, but it's a brain chemical imbalance issue. So here's the drug to balance your brain chemicals, and maybe you should talk to somebody. And that's pretty much it, right? There's no acknowledgement about the root cause factors that are perhaps disturbing neurotransmission in the brain. And these days, the monoamine theory, the brain chemical imbalance theory, has largely been replaced by more modern and expansive theories about mental illness, such as the neurotrophic theory, looking at the role of neurotrophic factors in mental illness, neurodevelopmental disorders, and neurodegenerative conditions. Or we have the cytokine theory, which is more so focusing on the role of anti and pro-inflammatory and pleiotropic cytokines and how that impacts the activity within the central nervous system. So I teach how to approach all of this, so that way we're able to really enhance client and patient outcomes. So this is where I coined the phrase microglial activation syndrome, which I think is a much more physiologically accurate and well studied and validated concept, as opposed to some of these other more common marketing narratives that we get from big pharma, right? So a lot of my work is really centered around looking at what root cause factors are disturbing the glial cells of the central nervous system, specifically the microglia, but of course also the macroglia or astrocytes as well. So a lot of my lectures, I'm exploring some of these root cause subjects. Now, the ones that we're going to be looking at closer today is specifically going to be methylation, nitric oxide in the microbiome, which is encompassed by this succinct list that I have here. So ultimately, neuroinflammation and neuroplasticity, which is going to dictate how homeostatic the central nervous system really is, it's a balance of glial cell activity. Do we have more M1 pro-inflammatory cytotoxic glial activation, or do we have adequate and dominant M2 anti-inflammatory neuroprotective microglial activation? So essentially, if we want homeostasis in the brain, if we want neuroprotection of our central nervous system, we have to have the microglial cells working in our favor. And for the vast majority of Americans, they are excessively tipped towards this pro-inflammatory M1 phenotype, right? So we're going to explore this deeper. And this is why I created my own lab panel that I call the mental map. Now, MAP stands for Microglial Activation Profile. I thought it was pretty cool branding. And so this test, this panel, primarily blood, but also stool and urine markers as well, but primarily blood markers. Now, I look at a lot of very well-studied, clinically significant biomarkers that gives us a lot more insight into microglial activation, neuroinflammation, leaky gut, leaky brain, neurotransmitter dysfunction, neurotrophic dysregulation, oxidative and nitrosative stress, nutrient insufficiencies, methylation, cryptopyrrole, epigenetics, so on and so forth. I'm very proud of this clinical tool that I've developed, and I train practitioners on how to use it in their practice. And so with this as my primary tool, I can assess and gain insight into the microbiome, nitric oxide status, and methylation, as those are key areas that the mental map is designed to precisely assess and identify. So we have to keep in mind that 88% of Americans are metabolically ill, based on a study that was published in 2020, I believe. So this is how I would define what I call the standard American metabolism, which just so happens to create the acronym of SAM. So Uncle Sam is not really living his best life these days, and we need more functional practitioners like us to rise to the occasion to help people out. So we see, 70% of Americans are obese or overweight. About half the population is insulin resistant or pre-diabetic, lots of fatty liver, a leaky dysbiotic gut, hypertensive, leptin resistance, hormone imbalances, methylation issues, with about 1 in 3 Americans and individuals having at least one MTHFR single nucleotide polymorphism, metabolic inflexibility, and illness in general, leaky brain, neuroinflammation, the list goes on. So to me, I think some of the biggest links that we should be looking at: methylation, nitric oxide, microbiome, and that's what we're going to focus on with the rest of our time here. So for those of you that maybe are not deeply familiar with methylation, I've got a couple of methylation 101 slides that you can read through later. But ultimately with methylation, we're just talking about moving around a methyl group or CH3 functional group to change the structure and function of various molecules in the body, right? So this is going to be going on billions of times per second in every single cell in the body all day, every day, assuming that we have adequate genetic capacity, epigenetic expression, available substrate to fuel the pathways, cofactors, coenzymes to facilitate the enzymatic reactions. This is deep biochemistry that actually profoundly impacts well over 35 plus crucial biochemical pathways. So like I said, about 1 in 3 Americans are estimated to have at least one MTHFR variant. Now, with the MTHFR variants, there's really only 2 that people ever talk about or test: the 677, which is usually considered the worst MTHFR variant, and the 1298. But the reality is, there are over 14 MTHFR single nucleotide polymorphisms thus far that have been identified as being clinically significant. And we're only ever really measuring or talking about 2. Now, to further that point, while I love genetics, genetic-based medicine is very limited. And I think a lot of what I see in the industry with people kind of running wild with genetic testing, I think is very myopic. And I think it's very premature. It's estimated that we have about 20 to 25,000 genes in the human genome. And obviously the microbiome has about 100 times the genetic material. But if we're really focused on the human genome of about 20 to 25,000 genes, as of 2018, over 88 million single nucleotide polymorphisms have been identified in the human genome. And a very small fraction of those have really been identified as being clinically significant. So our understanding of the complexities and nuances of genes, polymorphisms, and the epigenetics is extremely limited, right? So we have to humble ourselves and recognize we really do not have a deep understanding of all these complex interactions. Perhaps if we have dysfunction within one genetic epigenetic biochemical pathway, perhaps we have another pathway that is able to compensate for that deficiency, if you will. So we have to be thinking dynamically with this. Now, let's keep this moving. Methylation defects and imbalances have been linked to a lot of chronic conditions, everything from cardiovascular disease, autism spectrum disorder, recurrent miscarriage, multiple neurodegenerative disorders, hormone issues, cancer, chronic pain, fibromyalgia. The list goes on and on. Methylation deeply impacts our health through a lot of different mechanisms, including some of these key functions, such as methylation and acetylation really regulate genetic expression. If we put a methyl group on a gene, we're essentially silencing it and slowing it down. If we stick an acetyl group on that gene, we're essentially speeding it up and turning on that gene. And genes are being silenced and expressed very quickly all day, every day. Like if you turn on a light and turn a light on and off, on and off, on and off, billions of times a second, all day, every day, in every nucleus of every one of your 30 trillion cells that make up your body, right? So again, we have to really think about how deeply these things are working. But cell division, DNA production, glutathione production, neurotransmitter metabolism, detoxification, nitric oxide production, which we're going to talk a lot about, phospholipid synthesis, creatine, carnitine, CoQ10, bile, myelination of our neurons, immune function, synaptic transporter expression so we can have healthy neurotransmission, methylation is extremely important to be objectively assessing. And it's not just with genetic testing. We have to assess the actual current state of methylation using sound physiological and biochemical biomarkers. So there's a lot of different SNPs that have been identified and studied in relation to methylation issues. Of course, MTHFR being the most popular and well-known, but many others, methionine synthase or superoxide dismutase or PEMT or MAO or NAT2. The list goes on and on. There's a lot of different polymorphisms that could be included in the methylation conversation. These are just a few of the more well-studied ones. So there's a lot of holistic environmental lifestyle root cause factors that are going to alter not only our methylation, but many other biochemical pathways as well. Free radicals and nitrosative oxidative molecules, different pathogen-associated molecular patterns like lipopolysaccharide, heavy metals, toxic burden, dairy antibodies, different polyphenols, medications, of course. There's many factors that we have to consider holistically that might be disturbing your client or patient's methylation. So for those that haven't ever really studied methylation, here's a simplified schematic diagram that I created that maps out the methylation cycle. Ultimately, we have to be ingesting adequate folate from dark green leafy things through the diet and or supplementing. And then we have to methylate that folate. And then we have to be able to hand off that methyl group to cobalamin to make methylcobalamin in order to essentially methylate and convert homocysteine into S-adenosyl methionine, which is our body's major methyl donor that we need to facilitate all of our methyltransferase dependent reactions, whether we're trying to metabolize estrogen or neurotransmitters or produce, phospholipids or creatine or carnitine, the list goes on and on. So without a optimal methylation cycle that again is going on billions of times per second, every cell of the body, we need constant supply of nutrients and cofactors without any interfering toxins or toxicants or metals or disturbing factors so we can optimize this biochemical pathway constantly. And so I want to highlight homocysteine is currently it's really considered the gold standard. If you're trying to assess methylation of what's going on right here, right now, methylation as a great blood biomarker and one of the core markers on the mental map is typically considered the gold standard. And what's a little bit ironic and disturbing, conventional medicine is starting to more routinely assess for the MTHFR polymorphism 677 and 1298, but they don't usually assess methylation or homocysteine as part of that picture. So essentially they're looking at the blueprint, but not looking at current status of methylation. So if a patient tests positive for one of the polymorphisms, they'll immediately prescribe a compounded nutraceutical with megadoses of methylfolate, methylcobalamin, methyl donors, maybe up to 15 milligrams of methylfolate and methylcobalamin, which is an insane dose. And they're doing it just because the gene, the polymorphism is there, right? You have to assess the current state of methylation in order to have the dose be appropriate. So I don't agree with how conventional medicine is currently going about it. And I hope that as functional providers, we can do a better job. Now, the main two biomarkers I want to highlight right here for the sake of the conversation I want to have is homocysteine and then a more exotic biomarker, not very well known, called neoterin. Both are core markers on the mental map. I use both with all my clients all the time. I find them both to be extremely valuable. Homocysteine is a noxious amino acid that can drive endothelial dysfunction. It can drive leaky brain. It can stimulate NMDA receptors and drive excitotoxicity and anxiety and excess glutamatergic activity. Neoterin is really a unique marker that's related to immune activation, specifically macrophage and microglial activation. But what's really interesting too, as we get more stimulation of neoterin through the GTPCH1 pathway within macrophages and microglial cells particularly, what we see that as neoterin goes up, bioterin or BH4, which is the major cofactor as illustrated here to produce nitric oxide through our nitric oxide synthase enzymes in order to produce dopamine in our catecholamines, in order to produce serotonin or tyrosine from phenylalanine. Without adequate BH4 or biotin, we can't produce any of this adequately. And what we see as homocysteine and neoterin go up and up and up, biotin availability is crushed. So while we can't currently measure biotin in the blood, it can be measured in the cerebrospinal fluid, but I don't think anybody is going to be doing spinal taps with your clients or patients necessarily. But if we have elevated values of homocysteine and neoterin in the blood, we can safely presume that bioterin, BH4, the major cofactor for serotonin and dopamine and nitric oxide, is inhibited, right? And this has serious health implications on virtually every aspect of your body. So this is a diagram I created to illustrate how homocysteine can stimulate NMDA receptors on your endothelial blood-brain barrier and on neurons and drive leaky brain, excitotoxicity, excess glutamate, compromised GABA, like I was describing. So this is where enter the miracle molecule nitric oxide. So the discovery of nitric oxide is considered one of the greatest accomplishments in cardiovascular medicine. It was proclaimed molecule of the year that I was born, 1992. I just dated myself. And it won the Nobel Prize in Physiology in 1998 and was awarded to 3 scientists that discovered the role of nitric oxide as a signaling molecule within the cardiometabolic system. So nitric oxide plays a crucial role in virtually every aspect of our health. That's why I'm so passionate about nitric oxide. It touches every facet of our physiology through so many amazing mechanisms. Now, classically, when we think of nitric oxide, we're thinking of vasodilation, primarily of the blood vessels, to facilitate perfusion, oxygenation to the tissues, blood flow, so that way we can deliver the oxygen to the cells, feed the mitochondria to produce cellular energy and ATP. For most people, that's as far as the nitric oxide story goes, but it gets so much more interesting. So with vasodilation of the endothelium of the vasculature, well, wait a second. Everybody's raving about lymphatic drainage these days. Let's do lymphatic drainage all the time. What do you think your lymphatic vessels are lined with? Endothelial cells, just like your blood vessels. So if we want to promote lymphatic drainage and lymph flow, we need nitric oxide to create vasodilation within the lymphatic vessels, no different than we need it to increase blood flow. There is no ability to heal without healthy blood flow and lymph flow. And guess what, ladies and gentlemen? Nitric oxide is what regulates both. So, this is such a foundational component. Now, being somebody that focuses a lot on mental and metabolic health, some of my favorite roles of nitric oxide is how it actually regulates neurogenesis. It actually modulates and regulates how neural stem cells mature into matured neurons and how those neurons get integrated into our existing neural networks. It has neurotrophic properties, neuroprotective properties. It's deeply involved with microglial activation in the neuroinflammatory process. It helps to regulate inflammation in the body and the brain and everything in between. It helps to regulate oxidative and nitrosative stress. It plays a crucial role in immune function and infection resolution. It regulates release of hormones from the hypothalamus and pituitary gland and regulates neuroendocrine hormone balance. It acts as a gaseous retrograde neurotransmitter and regulates the release of our other neurotransmitters like serotonin and glutamate and GABA, so on and so forth, facilitates wound healing and the growth of new blood vessels or angiogenesis, obviously deeply implicated in sexual health and function, which is another fun conversation we can have. Of course, exercise performance and recovery, which is my origin story of nitric oxide. When I was 17, 18 years old working at GNC, nitric oxide was a standard supplement. If you're a fitness junkie or, athlete or physique athlete or anything, we all use nitric oxide in that world to help with the pump, to help with blood flow, to help with VO2 in recovery from exercise, being able to train harder, perform better, recover faster. That's what we all think of as nitric oxide in the fitness world. So that's where this is so satisfying and fun for me to be here, 13 plus years later, lecturing about the clinical applications of nitric oxide beyond just, sports performance. Of course, cardiometabolic health, with cardiovascular disease being far ahead the leading cause of death for Americans, and even blood sugar dysregulation, with diabetes being, I believe, the 6th or 7th leading cause of death for Americans. So we should all be assessing and supporting nitric oxide in every single one of our clients. Now, if you don't know that much about the basics of nitric oxide, I included some slides to help you with understanding this colorless, odorless miracle molecule gas. So I can very confidently say that, get my face out of the way here, nitric oxide is implicated in all chronic disease, period. And I wanted to make a point with this slide. So here's the leading causes of death. We've got heart disease, cancer, COVID, accidents, stroke, cerebrovascular disease, chronic lower respiratory, Alzheimer's, diabetes, chronic liver disease, nephritis, nephrosis. And so I went ahead and pulled some really powerful papers on it was very easy to find plenty of research behind the role of nitric oxide in all of these leading causes of death, except for accidents. Now, certainly I could create a narrative of like, well, if you have low nitric oxide and low blood flow and poor cognitive function and poor metabolic health, you're probably going to be more susceptible to accidents, but we don't need to go there for the sake of this lecture. So some low nitric oxide signs and symptoms that you should be looking for in your client and patient population. Chronic fatigue and low energy is one of the first that comes to my mind. Gastrointestinal concerns, musculoskeletal pain, pale skin because we don't have good perfusion of those red blood cells. So then also the cold fingers and hands and toes and extremities, numbness, chest pain, swollen veins, erectile dysfunction, hormone imbalances. Peripheral neuropathy is a big one. Numbness, weakness, pain and tingling, or kind of pins and needles, right? Cognitive and mental health complaints, things like brain fog, things like anhedonia, depression, anxiety. Air hunger is one. That terminology usually resonates with people if you use like a symptom questionnaire to screen your clients and patients of, do you ever experience air hunger, right? Sort of that gasping for air, I need more air. So that terminology resonates a lot of times. Low immunity, poor exercise, tolerance, and recovery. So again, a nice graphic that shows just some of the crucial roles of nitric oxide, the vasodilation, of course, neurotransmission, inflammation regulation, oxidative stress regulation, platelet activation, so on and so forth. Now, classically, most people are familiar with nitric oxide in regards to the nitric oxide synthase pathway. This is our endogenous way to produce nitric oxide from the amino acid L-arginine, or L-arginine that's created from L-citrulline. But either way, we have NOS1, 2, and 3, neuronal nitric oxide synthase, which is produced obviously by neurons and cells within the central nervous system, inducible nitric oxide synthase, or NOS2, which is expressed by primarily immune cells, such as my favorite microglial cells. And then we have endothelial nitric oxide synthase, or eNOS, which is usually the most talked about in regards to blood flow and cardiovascular health. But again, endothelial, which is not just our blood vessels, but also our lymphatic vessels as well. Blood flow, lymph flow, in endothelial nitric oxide synthase. Now, nitric oxide synthase as an enzyme system requires quite a few cofactors, things like bioterin that we already talked about. Again, if you have high homocysteine and neoterin in the blood, bioterin is compromised, and this pathway is going to be really dysregulated and inhibited. NADPH, FAD, calmodulin, or as an intracellular protein, FMN, so on and so forth. So in order to have adequate nitric oxide status through the nitric oxide synthase pathway, that means we have to have a functional NOS enzyme, first and foremost, which there are many single nucleotide polymorphisms within the NOS genes themselves. And then, of course, what's the epigenetic expression of these NOS enzymes and the functional capacity of these NOS enzymes? A lot of people have what we call NOS uncoupling, which we'll talk about momentarily. But we also have to have adequate protein intake and amino acid intake, So we have adequate arginine, and then obviously all the cofactors supplied by a lot of different, B vitamins primarily, and various methyl donors, for example. So there's a lot of things that can go wrong with the nitric oxide synthase pathway. Now, as we age, we naturally lose our NOS functionality. So as time goes on, as we age, as we undergo immunosenescence, or the aging of our immune cells, and the concomitant inflammaging, or AKA inflammation and oxidative stress, is creeping up in your body because your immune cells are getting old and can't regulate it anymore. So we start losing our nitric oxide production pretty steeply, especially after the age of 40. Now, here's a strong point I want to make, though. I don't want anyone in the audience walking away thinking, well, I'm under the age of 40, so this doesn't apply to me. No, we're seeing chronic inflammatory and oxidative chronic disease in younger and younger people. Now we have children less than the age of 10 with diabetes and obesity. So anytime an individual has a chronic disease, regardless of their age, they're going to have inhibited nitric oxide deficiency, and likely are going to have NOS uncoupling. So this is a huge issue that's relevant for all of your clients and patients. So here's a couple slides that you can learn more about nitric oxide synthase uncoupling. Essentially, what happens is when there is more inflammation, more oxidative stress, the NOS enzyme becomes dysfunctional. And instead of producing our miracle molecule, nitric oxide, it ends up producing superoxide, which is a free radical that then can add fuel to the fire of oxidative nitrosative stress and inflammation. So again, as inflammation and oxidative nitrosative stress are creeping up in your clients and patients with chronic disease and chronic health complaints, it is strongly likely that they have some degree of NOS uncoupling. There's a lot of ways that we can correct NOS uncoupling through removing some of the hidden stressors that are burdening their system holistically, for one thing, but also supplying cofactors, giving more dietary nitrate, trying to decrease the oxidative stress and inflammation, just to name a few therapeutic strategies. But you can check out the slides for a little bit more detail. Just for the sake of time, I want to make sure we get through everything. So this is where I want to introduce you all to the nitrate pathway. In my clinical education, career, and experience, I'm really finding most practitioners are not familiar with the nitrate pathway. Most practitioners have heard of nitric oxide. Some are a little bit more educated than others. Some might know about the NOS enzymes or NOS uncoupling and NOS single nucleotide polymorphisms. But I'm really finding that the majority of practitioners that I work with are not familiar with the nitrate pathway. So I want to introduce that. So with the nitric oxide synthase pathway, like I have hopefully clearly mapped out, a lot of things can go wrong there. But we have another source of nitric oxide, which is dietary nitrate. Dietary nitrate should absolutely be considered an essential nutrient. It probably will be eventually. Now, a lot of times people think nitrate, nitrite, isn't that like the harmful thing that you eat from like hot dogs and cured meats? Because it's associated with some of the food processing techniques where something like potassium nitrate is put in as a preservative to keep the cured meats like bacon and ham and hot dogs fresh and prevent Clostridia overgrowth or bacterial contamination. So that's kind of where that narrative is really thought of. But nitrate, dietary nitrate in its pure form, comes from whole foods from the earth, particularly dark green leafy things, our spinach, our kale, our bok choy, arugula, beets. Beets in particular, very rich source of dietary nitrate, depending on soil quality and where it was grown. But I digress. This is why we've seen so many beetroot extract supplements hitting the market as, athletic performance and nitric oxide, because beets are a natural source of dietary nitrate. Now, not all beetroot is created equal, and there can be issues with that, but I digress. The conversion of nitrate to nitrite as it gets reduced from nitrate to nitrite to nitric oxide. So essentially the way that this works is, let's say we consume a big dark green leafy salad with some beets on it, right? Very rich in dietary nitrate. Now, our oral microbiome can actually convert through non-enzymatic reduction reactions and convert that nitrate to nitrite. Further, a lot of nitrite is stored in the salivary glands. There's a unique protein called sialin that was discovered about a decade or two ago. And what happens is we actually swallow this nitrate from the saliva, and we're consuming this nitrate from the diet and converting it to nitrite. So we end up with this beautiful system through the gastrointestinal tract, starting with the oral microbiome, then the acidic stomach environment, and then your gastrointestinal microbiome. And this regulates the conversion of nitrate to nitrite to nitric oxide. And the literature describes this as essentially like a nitrite reservoir, where essentially the gut microbiome, the oral microbiome, is determining how much of this nitrate do we need to convert to nitrite or nitric oxide. So we have this sort of infinite pool of nitrate and nitrite to pull from to manufacture nitric oxide on demand. Keep in mind, nitric oxide has a half-life of a few milliseconds, right? So it's here and there, it dissipates very quickly. We have to have enough nitrite to convert into nitric oxide to supply a constant demand for nitric oxide all day, every day. This is why nitrate really needs to be considered an essential nutrient. So I've mapped out the steps by which we ingest dietary nitrate, and our oral microbiome can convert that into nitrite. We also are essentially juicing our oral cavity with saliva that is rich in nitrite that was extracted from the blood. Our salivary glands contain about 10 times the amount of nitrite as the plasma. So we can actually measure your nitric oxide status by measuring salivary nitrite with non-invasive test strips at home, which is really cool technology. So it's through this nitrate, nitrite, nitric oxide pathway that, assuming that we're supporting it and feeding it adequately, and we're supporting a healthy, diverse garden of life that is the microbiome in the oral cavity and gastrointestinal tract, we can be able to manufacture nitric oxide as needed anytime, all day, all the time. And this is really a pathway most practitioners and most people are not familiar with. And this is the pathway we need to leverage to circumvent all the issues that can arise with dysfunctional nitric oxide synthase enzymes. So this is the future of nitric oxide, and this needs to be clinically applied with all clients and patients across the board. Now, there's a lot of factors that can obviously influence this process. First and foremost, are you consuming enough dietary nitrate? Most Americans are not. Let's be real. How many of your clients and patients are eating adequate dark green leafy vegetables or beets and everything? Very, very few. And then think about how many clients and patients in the functional medicine space are worried about oxalates and trying to consume a low oxalate diet. Okay, some people might need to avoid oxalates, but here's the issue. A low oxalate diet, by definition, is going to be a low nitrate diet. So maybe they benefit from not consuming as much oxalic acid, but they're not getting enough dietary nitrate, which can possibly cause more harm than the benefit of consuming low oxalates. You know, or then what about carnivores? Carnivores are eating virtually no dietary nitrate, right? So there's a lot of conversations to be had here. We don't have time to get into all the nuance, but dietary nitrate intake, oral health and microbiome composition, right? Most Americans are using chlorhexidine-based mouthwash, fluoride toothpaste, have, oral microbiome dysbiosis. So then we get a lot of periodontal disease and even endotoxemia through the oral cavity, stomach acidity, right? Maybe about 200 million Americans are using, proton pump inhibitors or have low stomach acid, which can hurt the conversion of nitrite into nitric oxide. The gut microbiome composition, of course, because, it's almost like the first line of defense with the oral microbiome. And then step 2 is down in the gastrointestinal microbiome. And of course, individual variability, genetics, diet, overall health, so on and so forth. So here's a good schematic. Get my face out of the way so you can see it. That shows this pathway of, we eat that nitrate-rich meal, for example. and that swallowed nitrate will pass into the stomach and then into the intestines. A lot of nitrate is absorbed in the small intestine. So then plasma nitrate and nitrite concentrations will rise. About 60% is excreted in the urine. And then, like I was saying before, we actually store a lot of nitrate and nitrite in that salivary gland, where then we can recycle it back into the oral cavity, back to that oral microbiome to convert it into nitrite and the nitric oxide as needed to have powerful systemic effects on our overall health. So these are some of the major nitrate and nitrite reducing bacteria. This is a non-enzymatic reduction through the oral and gut microbiome. So some of the oral microbiome bacterial species that facilitate this conversion and gut microbiome. And most Americans have depleted microbiota, both of the oral cavity and gastrointestinal. So some of the factors that might reduce denitrification or reduction of nitrate to nitric oxide is going to be like a high sugar diet, not eating enough greens, too many processed meats, poor oral hygiene, periodontal disease, metabolic disease, immune system health, salivary flow rate, age, medication. Are they vaping? But, the fluoride toothpaste, the chlorhexidine mouthwash, or even, in the holistic space, people that might be doing coconut oil pulling. Coconut oil is antimicrobial in nature, or using too many antimicrobials. So we have to make sure we're supporting a diverse, healthy garden of life, plenty of dietary nitrate, prebiotics, probiotics, immunoglobulins, so on and so forth. So some different graphics to check out, but I just want to make sure we're able to get to all the fun clinical pearls. So a diagram about leaky gut progression. I trust we're all familiar with leaky gut here. But again, there's another story to tell in regards to the more dysbiosis and leaky gut or leaky mouth, right? Dysbiosis of the oral microbiome, dysbiosis of the gut microbiome, leaky mouth, leaky gut, leaky brain. All of these things are going to increase well, first off, PAMP translocation and toxin translocation, right? We get this leakage of all of these, pro-inflammatory, pro-oxidative toxins, food antigens, so on and so forth. The lipopolysaccharide endotoxemia, mycotoxins, heavy metals, gluten proteins, the list goes on and on. So as we get this pathogen-associated molecular pattern, toxin, toxicant, food antigen translocation systemically, it drives a lot of immune activation and oxidative stress and inflammation, which then further inhibits and drives nitric oxide synthase uncoupling, right? So even by improving microbiome health and sealing up any leakiness, we can protect the nitric oxide molecule more effectively through the nitric oxide synthase pathway. And this is where the dietary nitrate can be so powerful, because it can restore function to the NOS enzymes, as well as act as a prebiotic and give us that substrate for constant adequate nitric oxide production. So here's a nice diagram I created about leaky brain progression that illustrates essentially what I was just ranting about. An image that maps out a lot of the technical mechanisms of endotoxemia or lipopolysaccharide translocation. This can happen in the oral microbiome and drive a lot of neuroinflammation. It can obviously happen in the gut microbiome, as illustrated here. But those lipopolysaccharides are a major stimulator of that neoterin molecule that I was telling you about before. And this will actually stimulate inducible nitric oxide synthase that can actually contribute to oxidative stress or inflammation in the body and the brain through the activation of some of these immune cells. So nitric oxide, it's a complicated story, but what I'm painting is a picture of how we can restore optimal nitric oxide status, methylation status, and microbiome diversity and ecosystem health. So great illustration on the gut-brain axis that you can take a look at and study. It's essentially illustrating the same thing as the last diagram, just maybe with a different layout. So we've got the vagal pathway, humoral pathway, neuroendocrine pathway. We want a diverse, stable garden of life, healthy integral mucosal barrier, intestinal lining, plenty of short chain fatty acid production, which is neuroprotective and anti-inflammatory, as opposed to a lot of leakage and inflammation and dysbiosis that drives a pro-inflammatory, pro-oxidative phenotype here. So let's take a brief look at a quick case study. I just want to illustrate a few points here. So 53-year-old female with chronic illness, weight loss, resistant sleep apnea, constipation, suspicious of mold, a lot of unresolved trauma, a lot of severe symptom clusters across all of her physiology. We did extensive testing with the mental map and celiac and Lyme testing, thyroid panels, you name it, we've done it. I've done more lab testing on this client than anyone ever. There's a huge backstory we don't have time to get into. But I want to just show you some of her fluctuations and biomarkers over the course of time as we worked on a lot of these pillars that I'm passionately teaching here, right? So over the course of time, you can look at this outside of the lecture time to look at all the numbers. I made it very easy to read. Red is it got worse, blue is it got better. So we're tracking her physiology over time using some of the core mental map biomarkers such as C-reactive protein, that neoterin molecule that I am making a strong point of, cryptopyrrole, myeloperoxidase, metalloproteinase 9, homocysteine, copper to zinc ratio, histamine, tryptase, tissue transglutaminase, leptin, calprotectin, neurofilament light chain. I train practitioners on how to utilize all these biomarkers regularly, so we don't have time to teach all of it right now, but if you're interested, there's more content elsewhere. So this shows objectively how we've been able to help her improve her physiological functioning through a lot of the strategies that I'm teaching here. So I want to try to tie a nice bow on this presentation, bringing all of this together with summary and action steps. So we have to keep in mind the majority of the American population has metabolic illness, methylation issues, nitric oxide deficiency, and microbiome disturbances. This is not really unique. This is across the demographic board here. All chronic disease is characterized by elevated oxidative and nitrosative stress and inflammation, period. Nitric oxide is implicated in all chronic disease, period. It is a miracle molecule to help regulate oxidative stress, inflammation, and so many other things like we talked about earlier. Methylation-dependent reactions are crucial for a myriad of therapeutic pathways, including nitric oxide synthesis through the nitric oxide synthase enzymes. Now, to get even more fun with it, think about what I said before. When we stick a methyl group on a gene, we are essentially silencing the gene. So imagine if you had somebody that has MTHFR and methylation SNPs, but they also have nitric oxide synthase SNPs. And what happens if their nitric oxide synthase SNP is excessively methylated and silenced, right? So there's a whole conversation on genetic predisposition to methylation issues and nitric oxide synthase issues, just to stay focused on the topics of this presentation and ignore all the other important SNPs, but also with the way that methylation really regulates epigenetic expression and regulates the expression of the NOS enzymes. So we have to think about genetic predisposition, epigenetic expression, environmental, psychological, and lifestyle factors that are altering the epigenetics, either for better or for worse. And then, of course, what therapeutic strategies can we use to circumvent and mitigate some of this? So I postulate, I argue, I really encourage you all to consider focusing on restoring microbiome diversity with different therapeutics that I'll show on the next slide, improving GI integrity, nutrient insufficiency, nitric oxide status, and optimizing methylation so we can efficaciously help our clients heal. Microbiome therapy, nutraceuticals, and nitric oxide support should, in my opinion, be the foundation of all healing programs. So some of my favorite therapeutic strategies that I start most of my clients with, and obviously I customize dosage based on lab testing. I make sure to meet them where they're at and keep the coaching psychology healthy. I don't just force all these supplements upon them. It's always a two-way street of, do you want to take supplements? How many supplements do you want to take? What's a healthy, comfortable budget to allocate towards supplements? Which supplements that I'm recommending resonate most with you, right? It's a process. But as far as some of my favorite supplement recommendations to optimize methylation, nitric oxide, and the microbiome are these here on the screen. So I'm wildly passionate about serum bovine immunoglobulins. I actually have my own product, which can't quite see on the shelf over here. I have my own immunoglobulin product, but the serum bovine immunoglobulins used to be a medical food available by prescription only. The medical prescription dose would be 10 grams 3 times daily or 30 grams a day. I usually use anywhere from 2 to 5 grams, 2 to 3 times daily with most of my clients, and I'm never afraid to increase the dose as high as they're willing to go. They work so well. They have prebiotic-like properties. They bind and neutralize a lot of the pathogen-associated molecular patterns that we talked about earlier. It can bind gluten proteins. It can bind and neutralize lipopolysaccharide, mycotoxins, microbial components. So it acts like a defensive shield in the gut to support whole body health, and they don't absorb systemically. Of course, I'm a huge fan of probiotic therapy. Both spore and non-spore forming strains can be great. Some of my favorites: Bacillus coagulans, Lactobacillus plantarum, Bacillus subtilis, Saccharomyces boulardii. The list goes on and on. Omega-3 fatty acids. There's a reason why they are essential nutrients, essential fatty acids. So I'm huge on omega-3 fatty acid therapy. Methylated B vitamins, particularly methylfolate. Sometimes folinic acid might be better tolerated by some of your clients with MTHFR and COMT and MTR, so on and so forth. So consider folinic acid if they're not responding well to methylfolate as a clinical pearl. But generally speaking, methylfolate, methylcobalamin, pyridoxal 5-phosphate, riboflavin 5-phosphate, a good, well-rounded, B complex with methylated Bs or folinic acid, like I said, maybe some trimethylglycine, so on and so forth. And I based the dose off labs, of course. Zinc, huge one, so I could lecture all day about zinc, but for the sake of time, usually a picolinate, bisglycinate, carnosine, maybe arginate, 15 to 45 milligrams for most people, but you got to base it on plasma zinc in the blood, which is on the mental map. Magnesium, usually 600, 1200 milligrams daily, obviously titrating accordingly. But that dietary nitrate that I was telling you about before, I use dietary nitrate with all my clients every day. I use it myself every day, about 500 milligrams daily. Of course, try to get as much nitrate from your diet as possible, your dark green leafy things, your beets. But let's be real, it can be kind of hard to get all of that. So supplementing with dietary nitrate is a great way to go, and using salivary nitrite test strips. So that way you can use them daily to guide how much nitrate do I need today, depending on the result of the salivary nitrite testing strip, which you can get through even Fullscript has them. Acetyl L-carnitine, could rave about all day, but usually about 1 gram 3 times per day. Has a lot of amazing neuroprotective properties. Same with creatine. So I usually will recommend acetyl L-carnitine, creatine, about 5 grams daily for most people, and acetylcysteine, another powerhouse, which actually protects the nitric oxide molecule really, really well as an antioxidant. And then vitamin D3 and K2, of course, for all of the many properties there. So at the end of the day, we need to be spending more time tracking physiology than chasing root causes. And this is what I'm all about. I practice this, I preach this, I teach this to my practitioners, students, and mentees. So again, we really need to make sure that we're spending more time tracking physiology objectively using well-studied clinical biomarkers than chasing root causes with all the fancy functional lab tests. I really implore you to consider that. So, action-packed conversation. Thank you so much for your time and attention. I hope you enjoyed the presentation. I hope it gave you some things that you can immediately implement into your practice, of course. And if you want to stay connected or learn more, you can get in touch through info@metabolicsolutionslc.com or my website, metabolicsolutionslc.com. And of course, you can follow me and my work on social media at The Holistic Savage. It was truly an honor to have the opportunity to share this work and knowledge with you. And I hope to connect with you soon and stay connected and continue learning and growing with you all. So thank you so much. Have a great day.